It is the afternoon of Wednesday, January the 13th, and I'm going to talk to you about something called the mirror equations today. These equations can look a little intimidating, but they're actually not that tough. There's two different equations. I'm going to start with the one that's 1 over the focal length equals 1 over the distance of the object plus 1 over the distance of the image. So what is the focal length? We know the focal length is the distance from the mirror to the focal point, which is halfway to the center of curvature. What is the distance of the object? It's the distance of the object to the mirror. And what's the distance of the image? It's the distance from the mirror to what the image is. So you can find any one of these three variables using this equation. So what I've done here is I've purposefully left off the distance of the image so we can solve for that. So we have 1 over f equals 1 over do plus 1 over di. Once again, do, f, and di is to here. So we're trying to find out how far this is away without measuring it. So we have 1 over f, which is 2.5, equals 1 over do, which is 1 over 6.5, plus 1 over di. So let's divide 1 by 2.5 and we'll get 0.4. So 1 divided by 2.5 is 0.4. We'll do 1 divided by 6.5. And that's equal to 0.15 plus 1 over di. Now, what we're going to do is we're going to bring the distance of the object over to this side. So we have to subtract 0.15 from this side to get rid of this. So we'll subtract 0.15 from this side. That's 0.25 equals 1 over di. Now, whenever you're using this equation, we can't solve for a variable when it's on the bottom. So what we have to do is we have to flip this. So the rule in math is whatever you do to one side of the equation, you have to do to the other. So what you do is you imagine that 0.25 is the same as 0.25 over 1, so you flip both sides. So you've got 1 over 0.25, because I flipped that, equals di over 1. And I'm not going to write the 1 down because di over 1 is just di, but I could write di over 1. So di is going to equal to 4. So the distance of the image should be 4 centimeters away. Now, if I measure this, I'm off. And the reason that I'm off is because I did not round properly here. So if I did this, if I'd rounded properly, I would get a better answer right here that would be closer to the real one. But what I wanted to do was use easy numbers here in my calculation. So you can use this formula right here to find out how far the image is away from the mirror, how far the object is away from the mirror, and how far the focal point is away from the mirror. Let's look at this formula here. This tells you the magnification. So how much times bigger is this than this? Well, it's not. It's a lot smaller. So it's not 5 times bigger. It's not 10 times bigger. It's about 1/10 the size of this one right here. We can do that by looking at two relationships. The height of the image, that would be this height here, over the height of the object, or the distance of the image over the distance of the object. So, if we want to know the magnification, we can split this up into 3 separate smaller formulas if we want. So we can split this up into 3 smaller formulas. Let's say we want to know the magnification. We said the di over the do is equal to negative 4 centimeters. So in the last formula, we found the distance of the image was 4 centimeters away, over the distance of the object, which on our diagram is 6.5 centimeters away, 4 divided by 6.5 equals 0.61. And there's a negative sign in this formula. It's negative 0.61, meaning what's happened is it's gotten smaller. Okay, so a negative magnification means it's gotten smaller. Now, if we did the same thing using the height of the image and height of the object, we wouldn't get a negative sign, but the reason you'd put a negative sign in is because this image is negative. It's not getting taller, it's going down, so we'd automatically put a negative in there. Now, the other thing we could do is we could measure the height of the image using this formula. So let's do this. So all I did was I took a look at this whole formula and I split it up just into this part right here. Remember, this formula can be made into 3 separate formulas. So we are looking for the height of the image. So we want to know how tall this is right here. If we know the height of the object, it is about 1.5 centimeters. So I just measured that. The distance of the image we said was 4 centimeters. And remember, this formula's got a negative in it. And the distance of the object we said was 6.5 centimeters. So if I cross multiply, or I have to multiply both sides by 1.5 to get rid of that 1.5. Four times 1.5 equals, divided by 6.5 equals. That's 0.92 centimeters. Now, oh, sorry about that. That's 0.92 centimeters. If we take a look at this, I have done something wrong. And what I did